right, so congratulations, we've reached the end of another course section. So as always, let's take a few moments to review everything that we learned. We first began by learning about the JSON server and Axios NPM libraries. JSON server is an NPM library that allows us to emulate a backend/server. The way we do that is we define a JSON file with endpoints or routes, which basically just means URLs, and we specify what that JSON server should return when that endpoint is hit. So it's almost like we're setting up some kind of website, some kind of API that's just going to return data to us. And this was the simplest way that I could think of that we can get essentially a backend up and running that we could hit with the React app in order to fetch data. But of course, in order to make that request from the JavaScript/React side of things, we needed an additional library, and that was Axios. The Axios NPM library makes the actual request to the endpoint that we set up with JSON server. Of course, in the real world, you would still use Axios, but you would make a request to an actual URL or an API endpoint that would probably be provided by your team or your backend developer. So this was just a good way for us to go through that flow, a real world example, but in a much more confined and kind of limited space. All right, the next thing we talked about was lifecycle methods, and a lifecycle method is just a method that automatically runs one or more times during a component's existence. It's called a lifecycle method because it's a function that executes at some point during the component's life, right? So some examples that we explored were component did mount and component did update. Component did mount runs once after the component is mounted to the DOM in the browser. And as we saw, that was a great place for us to make our API requests using Axios because we allow the component to load first on screen and we give the user something to see. And then once that's loaded, we shoot off that request, which can take off some time. And once we receive the request, we can save the data to state and force a re-render, and the user gets a much more enjoyable experience. Because, for example, if we delay the render of the component until we get a backend response, say that response is really slow, or say it never comes, maybe it's an error or a failure. In that case, the user gets nothing on the front end, they don't get any kind of component, and that is a much worse user experience. We also talked about the component did update lifecycle method, which is an example of a lifecycle that runs multiple times or has the potential to run multiple times during a component's existence. It will run every time either the state or the props of the component update. So we utilized that method in order to make a fresh request to our JSON server backend whenever the user typed a character to search for a user, and we wanted the backend to filter that batch of results. That was a perfect example of a side effect, or in other words, an additional operation that we needed to do in a class component that was separate from the actual render. Remember, React has no opinion on what libraries you should use to make API requests or anything like that. It wants to focus on the view layer. It wants to focus on the rendering of JSX elements to the screen. So it provides these additional methods so that we can hook into them and perform these additional bits of logic that our business needs, right? But the kind of library we use to make requests or how we wire up that logic throughout our app, there is a lot of room for variety and experimentation, all right? So I just showed you one very popular approach. As we talked about, be careful not to trigger an infinite loop in your component did update lifecycle method. The way you can accidentally trigger an infinite loop is if you set state, because the setting of that state will cause the component to rerun the component did update. And so that cycle will continue infinitely. So the way you prevent that is by adding some kind of if statement that's usually going to compare some piece of state with another piece of state to check whether you should run that logic again, all right, and avoid that infinite loop, whatever is causing it, right? So be careful whenever you are updating component state in a component did update lifecycle method. Finally, the last thing we talked about was mock functions in jest. A mock function is just a replacement or a stand-in that we can use for a real function. And the reason we do that is to replace complexity, especially when it comes to things like testing. We don't want to use either the real Axios library or have to set up a real server, an API server, in order to test a component that is rendering cards to the screen. It is overkill and it creates a lot of complexity in our tests, right? We have to set up a separate server that is going to run to return data in that instance. And even if our component is totally fine, if, for example, our fake backend in our tests is broken, then our test will fail even though it has nothing specifically to do with the component. So we want to create some separation between the tests of our component and that separate part of the system. So we simply intercept a sample function like axios get, and we replace it with a mock. And that is just one example of something that you can mock out. There are many others. Basically, whenever you are potentially relying on another library's code or some kind of complex method that will take some time or require some dependencies, you can simply use that jest syntax to overtake that original implementation, kind of intercept it, and replace this with this function that can serve whatever role you want. As we saw, we can customize a mock function to return whatever value we want. It can be a plain data type, or it can even be something like a promise, an asynchronous data type that is resolved after a set amount of time. Another benefit of a mock function is that it can track how many times it has been invoked along with what arguments, and that can be used to verify that your component or whatever it is that you're testing is interacting with the mock function in the correct way. So it's not really about the mock function, right? It's about testing, in our case, that our component was interacting with axios get in the correct way without actually relying on the real axios get implementation, which is obviously more complex and not needed, right? What is important is the interaction or the communication between our code and another library's code, but we don't want to worry about the internals of that library and how it gets the job done. The tests for the axios get method are found in the axios codebase. There's no reason for us to double validate that by running through the full functionality of that method in our own component code. We want to focus on testing our component, that is our code, that is our business logic that matters to us. Finally, we saw that the jest.mock method is available. Jest is just your global jest object that is available in any test file, and mock is a top-level method on that object. That will replace all of a NPM library's exports with mock functions. So we use it to mock axios, but you can obviously use it to mock any NPM library in the world. You can actually even mock your own files. So if you have, for example, a component relying on a complex class of yours that takes some time to perform some expensive computation, and you don't want to run through that in a test, you can actually mock out even your own code. It doesn't even matter whether it's yours or somebody else's. What's mattering is that we are replacing or stubbing in a replacement for the original implementation so that we can have a more isolated unit test. We are focused on testing the component. That is what we care about. And if there are any dependencies it needs that add a lot of complexity, we can replace those with our mock functions, and we can do that automatically using jest.mock. All right, so hopefully there was a lot of fun things that you learned in this section. In the very next one, of course, we're going to refactor our current design to use functional components and hooks. So once again, you're going to see the evolution of the React library over time. Lots of fun stuff up ahead, and I will see you in the next lesson.